Okay, lesson 3, we're going to solve quadratic equations by graphing and factoring. Okay, and this is something that we did do at the beginning of this class, and so we're going to do it a little bit more today as part of this quadratics chapter. So one of the things that we're looking for when we're solving equations for quadratic functions is we're looking for the zero of a function. So that's the values of x that make the answer equal to 0, or we could think of it as the x coordinates where it crosses the x-axis. So where the y value is equal to 0. So, unlike linear functions, which have only one 0, quadratic functions could have 2 zeros, or they could have 1 0, or they could have none, depending on the situation. So we're going to first of all look at finding zeros by using a graph or a table. All right, and we're actually going to use your calculator to do this with the graph and the table. So take out your calculator. And put that function in your y equals. Hit zoom 6. Should look like that. Excuse me. Thanks. No, you shouldn't have. That just shows up on my calculators. Okay. Your calculator's broke. All right, let me see what you got. That's because you put negative 6x instead of minus. Okay. Now, if we look at this graph, can we tell where this graph crosses the x-axis at? Okay, we can. All right. So it appears it's at 2 and 4, right? How can you verify that with your calculator to make sure it's there at 2 and 4? Okay, you can go to your table. All right, so go to your table and look there. How do you get to your table? Second graph. So I can look at the table, and I can see that, oops, I need to change my window. Oh, not my window, my table set up. All right, I can see that when x equals 2, y is 0, and when x equals 4, y is 0. Okay, so I can look there, or I could look at hit the trace button. And because it looks like it's 0 at 2, I can type in, after I hit trace, I could type in 2 and enter and check to see if it's 0 there. And I could type in 4 and enter and see if it's 0 there. Okay. So it says find the zeros by using the graph and table. So my answer then would be the zeros are at 2 and 4. Okay. So we'll be using looking at our graph and table for doing them. So find the zeros for this function. All right, so when we're finding zeros of a function, another word for that or phrase for that is to find the roots of an equation. In other words, we take off the function part f of x and set it equal to 0. And then we say that now it's an equation, so we're trying to find the roots of an equation. And the roots of the equation are basically the same thing, the solutions to the problem. So I need to find the values of x that make it true. And so we're going to use what's called the zero product property. This is something we've talked about before. And we're going to be using factoring. Okay? So hopefully your factoring skills are all good and ready to go. So this says find the zeros of each function by factoring. So the first thing I'm going to do is I'm going to set it equal to 0. So I'll rewrite it so that it's equal to 0. And then we're going to factor. So we have x squared minus 4x minus 12 equals 0. So what do I get when I factor x squared minus 4x minus 12? Okay. All right. Caleb says we get x minus 6 times x plus 2. So negative 6 times 2 is negative 12, and negative 6 plus 2 is negative 4. Okay, that's correct. Okay. So now, if you remember when we talked about the zero product property before, this means then that we are looking at here that if a times b is equal to 0, then either one part of it is equal to 0 or the other part is equal to 0. So that means then that either x minus 6 equals 0 or x plus 2 equals 0. So if that's the case, then x is going to equal positive 6, because I'll add 6 to both sides, or negative 2. Okay. And if you remember when we talked about this before, we always said that if it was just one x, then the 0, when we have it in factored form, is always going to be the opposite. That's right, Jordan. Always going to be the opposite. All right. Now, you could take your calculator and you could check to see if this is correct. Okay. I could type it in, look at the graph, see if those are the right zeros or not. Okay. All right. Let's look at letter B then. All right. 3x squared plus 18x. Now remember, whenever we're factoring, there's always one thing we're always looking for first. What is it? Okay. Something they have in common, okay? Close. Nope. Greatest common factor, okay? It's the greatest common factor. So we're always looking for that. So we didn't look at that with the first one, but in letter A, do those three have anything in common? X squared, 4x, and 12. Do they have anything in common? No, they don't have any numbers in common, no variables, okay? So we couldn't factor out a greatest common factor, okay? In this case, 3x squared plus 18x. So first of all, I'll rewrite it as an equation. So do 3x squared and 18x have anything in common?
3x.
Okay, 3x. So we take out the 3x, and we have x plus 6. Okay. Now, 3x would be my A, and x plus 6 would be my B. So then either 3x equals 0 or x plus 6 equals 0. So we divide by 3, and x equals 0 or negative 6. And we could check that. Let's see if we put that in our y equals or not. Put our y equals, we have 3x squared plus 18x graph it. Now, with the graph, does it matter whether I can see anything except for the zeros? No, all I need to know is where it crosses the x-axis. So if I hit trace now, I'm checking 0 and -6. So at 0, it's 0. Yep, okay, that's true. And now if I hit -6, check that, is it equal to 0 there? Yes, it is. Okay, so I did it correctly. Okay, so I can easily use my calculator then to check to see if it's correct. Okay. All right. Leaving it alone. Okay, any object that's thrown or launched into the air, such as a baseball, basketball, or soccer ball, is a projectile. The general function that approximates the height in feet of a projectile on Earth after t seconds is given below. Right? In your science classes, you may have seen this formula before for the height of an object. You got -16t squared plus v sub 0t plus h sub 0. Where -16 is gravity in feet per second squared. V sub 0 is the initial velocity. So, if it's dropped, it would be 0. If it's thrown up in the air, it would be a positive number. If it's thrown down, it would be a negative number. Okay? And the h sub 0 is the initial height. So if I dropped something from 6 foot, then h sub 0 would be 6. If I threw it and let go of it at 6 feet in the air, then h sub 0 would be 6 also. So when we work with questions with projectiles, then it's very important that you know where we're going. So we've got -16t squared for sure. Okay, that's a given part of it. Gravity doesn't change unless we go to meters per second squared instead of feet. Anybody know what it is in meters? No? Okay, it's 4.9 meters per second squared. So it says a golf ball is hit from ground level. What does that tell you? Okay, h is 0. With an initial vertical velocity of 80 feet per second, after how many seconds will the ball hit the ground? So we know that h sub 0 is equal to 0, and v sub 0 is equal to, is this a plus or a minus 80? Okay, it's a positive 80, right? So then I'm going to plug those numbers in. So we want to know after how many seconds will the ball hit the ground. So that means then that this number here, h of t, is going to be, it's going to be 0, okay? This is the height after so many seconds, okay, is what h of t stands for. So this is our ending height. Okay? So we're going to have h of t equals, let's write the equation first of all, -16t squared plus 80t. So there's our equation, because h sub 0 is 0. And then we want to know when this comes back to the ground, so we want to solve the equation -16t squared plus 80t equals 0. Yeah. Do what, Caleb? Factor it, okay? All right. So first of all, we want to look to see if they have anything in common. Do -16 and 80, do they have anything in common? Okay. All right. They do have a 2. But does 16 go into 80?
Yes. That's 5 times.
5 times, Carolyn says. Okay. So then, instead of factoring out 16, though, I'm going to factor out -16, and they both have a t. So what does that do to the sign here in front of the 80? Okay, that's going to make it a -5 and equals 0. Now, from these two numbers, we're going to get t equals 0 from -16t, and then t equals 5 from the other factor. Okay? Well, we already knew 0, didn't we? Because the ball was hit initially, where was the ball? On the ground when it was hit. So at time 0, the ball was at 0 height. All I need to know is when is it going to land back on the ground again. So it lands back on the ground in 5 seconds. So t equals 5 seconds. What's that? Yeah, hopefully. Right.
Oh my.
Okay. All right, now, we talked about also when we started this class, we talked about two other types of products. One of them was the difference of two squares, and the other one was perfect square trinomials. Okay? Both things that provide us with factoring opportunities. So when we have binomials, okay, lots of times we have difference of two squares, and sometimes with trinomials we have perfect square trinomials, and their factoring and everything is right here. Just some reminder of them. Okay? So when we want to find the roots, when we have those special kinds of factors, okay, then the thing is we still want to make sure they're equal to 0. So when we solve quadratic equations, the very first thing you have to do is get everything on one side. So we want it equal to 0. All right? So that's the first thing we need to do is get the equation equal to 0. So 4x squared equals 25. What am I going to do then to get that equal to 0 first? All right, we always want our x squared term to be positive. So the first thing we'll do here is we will subtract 25 from both sides. So we have 4x squared minus 25 equals 0. Okay. And now I have two terms. Okay. Do they have anything in common? No, they don't. Okay, because the 25 doesn't have x squared, 4 doesn't go into 25. Right? So I want to look. Do I have the difference of two squares then? We do. What number squared makes 4? 2. What number squared makes 25? Okay. So we have 2x plus 5 and 2x minus 5. Now, are my answers plus and minus 5 now?
No.
Because that would be the opposite of this and the opposite of this, wouldn't it? Okay. But would those be the right answers? Why not, Carolyn? Kind of, but not really. Clara?
I feel like you divide 2 or 5 divided by 2 and then get like x equals.
Yeah, I've got the 2 in front of the x, right? Since I have the 2 in front of the x, I can't just do the opposites. So I actually have to set these two equal to 0 and solve them then. So I have these equations that must be solved. Okay. So we're going to subtract 5. So we get 2x equals negative 5. And over here we're going to add 5. And then in both cases we're going to divide by 2. So x equals negative 5 halves or positive 5 halves. What's the decimal number there? 5 halves and negative 5 halves. What is that? 2.5. Okay, so if I need to check that with my calculator, I'm looking for 2.5 then. Okay. All right, let's look at letter B then. So what do I have to do first? Okay. Okay, so we got to subtract 48x and add 32 because I need to get it equal to 0, and I want my squared term to be positive. Okay. So we're going to end up with 18x squared minus 48x plus 32 equals 0. Now remember, when we're looking for factoring, okay, the first thing we're always looking to do is, do they have something in common? Do 18, 48, and 32 have a number in common? Okay, all right. Let's see. 2, does 6 go into 32?
4.
No.
3. No. 2.
All right, I think Gibson convinced himself it's 2. Okay, all right. 8 doesn't go into 18. Okay, 6 doesn't go into 32. Okay, so it's just 2. So we're going to divide everything by 2 first of all. So we have 9x squared minus 24x plus 16 equals 0. Okay. Now, we need to factor this. Okay, if we can. All right, and we can. Okay, this is a perfect square trinomial. I know that. Okay, but I can also. How else did we learn to factor this? How else did we show you how to factor these? Remember?
Slide and divide.
Okay. All right, something like that. Okay, slide and divide. Okay, so let's take a look at the slide and divide. All right. For slide and divide, the first thing we do is we multiply a times c. Okay. So what's a in this case? 9. And c is? All right. So what's 9 times 16?
144.
All right. So all we're worrying about is the factoring right now. So I'm gonna. All right. So we get 144. So we need to know the factors of 144 that add up to 24.
12 times 12.
What's 12 times 12, Elise? Oh, and what's 12 plus 12?
24.
All right. So,
Oh my god.
so we have x minus 12 and x minus 12. Hey, that's nice, isn't it?
Yeah.
They're the same. Okay? And then I have to do what? Divide by what? Divide by a. Okay, we factor, then we divide by a. So divide by 9. And what's 12 over 9?
1.
As a fraction, what is it? Okay. How about 4/3? Okay, and I can use squared then, right? Because there's 2 of them. Okay. All right, so then we need to move so then we've got to slide the 3 over here in front. So we have 3x minus 4. That quantity squared equals 0. So then I only have one equation to solve. 3x minus 4 equals 0. So x equals 4/3. Okay, are you good with that? Add 4 divided by 3. Okay, all right. Yes.
Do you need to slide it over? Like when you get 4/3 down there, do you need to slide it over?
Very good, Mr. Hart. You don't have to, do you? Because once I get to that point here, it actually is in the factored form that we like, which tells me right away that 4/3 would be my answer. Okay? Very good. That is correct. Okay? So now I want you to do this. Okay? I want you to go back to the 18x squared part. Okay? Nope. Okay? I want you to put this in your y equals. Okay, you hit zoom 6 at least. Okay. Now, how many solutions do I have in this case according to the graph? 1. It only intersects the x-axis once, so when you have a perfect square trinomial, there's only going to be one answer. And so if I hit trace and put in 4 divided by 3, we can see that it's equal to 0, and I checked it, and it is correct. Okay? All right. Now, let's go to the last one. 2550. Okay. All right. Now, the last one is we're going to go backwards. Okay? They give us the zeros, and they want us to write the function for it. All right? Now, this should be, okay, all right, the easiest part of this. Okay? All right? Because if we go back and look at everything we've done, oops. All right. The zeros here were at 2 and 4, okay? Which means then that we would have had what? X minus 2 and x minus 4 here, right? Okay? X squared minus 6x plus 8 would be x minus 2 and x minus 4. Okay? The zeros are the opposites, correct? Okay? When we did the factoring here, we had factors of, we had x minus 6 and x plus 2, which gave us a positive 6, negative 2. We had a 0 and negative 6 for answers here, which gave us 0 here as a factor, x plus 6. They're the opposites. So, here we have zeros of 4 and negative 7. So when I write it, so I'm going to write it in factored form first, which means I use the opposites, x minus 4 and x plus 7, and then you just need to multiply that out. And f of x equals that. Okay? All right? So we're just going to put it in the simplest form. And if you look at this graph down here, okay? Look at this graph down here. There's many functions that could have the same zeros, but we're just going to look at the most basic form of it like we have right here. X squared plus 3x minus 28. But there are many answers that would work. Okay? So what's the standard form for the quadratic function with 5 and negative 5 as zeros?